Hello, boys and girls. Today we are going to start a new lesson called Unit 4, Module 2, Session 1, Removal versus Differencing. All right. So in this lesson, we're going to begin with a problem string that will challenge you to consider two different strategies for multi-digit subtraction and when it is the best time to use each of them. So I know that we are familiar with subtraction, but I really want you to try very hard to see if you can actually embrace these two different strategies for yourself and see how it goes. All right. So we're going to go on to the next slide here. So remember that during the previous module, when we were back in school, that we solved problems that included people's ages and the years that they were born. I'm sure you probably remember that. It feels like forever ago. But today we're going to continue that theme, beginning with subtraction problem string instead of an addition one. So you're going to need a piece of paper or the back of your student journal for the problem string. So I'm going to give you a little bit of time to get yourself ready to go there. And we'll start in just a moment. All right. So go ahead and get yourself some paper. Okay. So I'm going to go ahead and get started here on the next slide. So for the problem string that we're going to do, this is the first problem. It's that Jason's grandfather is 82 years old. His grandmother is 79 years old. How many years older is Jason's grandfather than his grandmother? So you can see here that we're basically trying to figure out what 82 minus 79 is. Now, if you think about it, it's actually pretty easy to figure out this particular problem because all I really am looking at is these two numbers and seeing how many more this one is than this one, right? But really, there's a strategy for solving this problem. So you probably already know the answer, but I'm going to go ahead and flip on to the next slide here and you'll see what I'm talking about. So if you look at it on a number line perspective, so here we have this number line, right? I'm just going to go ahead and pick blue for fun. So you see the number line that I've drawn, right? And I've put 82 and I've put 79. So if I start, so this is called finding the difference strategy here. If I start at 79 and I jump to 82, you will see that I will have jumped 3 spaces, right? Or 3 numbers. So you should have gotten that 82 minus 79 equals 3. So thumbs up if you got that answer. All right, we're going to move on to the next problem in the problem string. So be ready. On to the next one. Here we go. All right, so the next one is, I have a friend who is 63. Her grandson is 5. How much older is my friend than her grandson? This one's a little bit different, but you can see here that we're trying to figure out what 63 minus 5 is. So can you tell that this one's different because we're starting with a larger number, okay, of 63, and we're trying to figure out how much less that smaller number is, okay? So we're going to look at a number line problem again, and on the next slide you'll see that if I were to start at 63 here, which is right here, okay, and if I were to just jump 5 spaces backwards, I'm going to end up at 58, okay? So this one's called removing or taking away. So this time I'm actually taking away 5, whereas in the last problem, if I jump back to that for a second, I was actually just finding the difference between the two numbers, which were closer together, okay? So in this one, I'm actually removing or taking away 5 to find what the answer is. So now I know that 63 take away 5 is 58. All right, so that was the second problem on our problem string. Let's go ahead and take a look at the next one here. So we're going to compare these two problems now, okay? So the first one is finding the difference, and I feel like I kind of already did this for you, but for finding the difference, you can already tell that these two numbers right here are fairly close together. If you take a look at them very carefully, you can see that they're really close together, actually. So it's kind of pretty easy to tell, you know, that you're doing a difference between 82 and 79. With the next one, though, you're actually removing or taking away a certain amount. So you're starting with a large number again, but then you're taking away 5 less. So your numbers are much farther apart, okay? So that's where the difference lies with that. All right, so here's the next problem in our problem string, okay? So if Uncle Terry was born in 1947, how old was he in 1992? So now we're actually working with numbers. We're actually trying to figure out 1992 minus 1947. So I'm going to give you a little bit of time to see if you can figure that one out, but see if you can figure out how to do it on an actual number line where you actually have 1992 and you have 1947, okay? Now, if I think about it, I kind of want to jump from 1947 to 1992, and I'm going to switch colors here. If I were to jump just a little bit to 1950, I will have jumped 3 spaces. Now, it's easier to get to 1992 from here because I know that from 50 to 92, it's 42 more spaces. So if I go like this and I jump 42, okay, I will figure out that 3 plus the 42 other spaces that I jumped is 45, okay? So you should have gotten 45. Now I'm going to jump onto the next slide and see if we actually got it correct, okay? So I'm going to switch to the next slide here. Now that's exactly what I did. Do you see what I did here? I jumped 3 spaces to make it a little bit easier. So this kind of makes me think of our give and take that we were talking about before we left school when we were doing addition. It's a little bit of, can I get myself to an easier number? Well, from 47 to 50 is only 3 spaces. So now I'm at an easy, solid number here, and it's much easier to jump 42 more spaces to get to 1992. So from there, altogether, I have jumped 45 spaces, which means that Uncle Terry, you can hear my son in the background, sorry, is 45 years old, okay? So there's that one. Let's go on to the next problem string, okay? The next problem. I feel like I might be going a little bit fast here, but hopefully not. I actually don't have a timer telling me how fast I'm going, so I apologize for that. I'm going on to the next slide here. So we have that if Cousin George was born in 1999, how old was he in 2005? Now you can see here that these 2 numbers are much closer together than the first 2, okay? So again, if I think about doing it on a number line, and I'm going to make my number line a little bit bigger this time so you can see here. All right, I'm going to go back to my smaller size. Maybe I'll go to that one. Okay. All right, so if I've got 1999, I know that that is very, very, very close to the solid number of 2000. Okay, so from 1999 to 2000, I've only gone 1 year so far, okay? But from 2000 to 2005, I know that that is an easier number to work with, so I now have jumped 5 spaces, right? So altogether, I have gone 6 because 1 plus 5 equals 6. So if Cousin George was born in 1999, how old was he in 2005? So we're trying to figure out 2005 minus 1999, okay? So I'm kind of doing a little bit of jumping from my later or my earlier year to my later year. So from 1999 to 2005, that is 6 spaces. So what I'm going to do here is flip slides again. And there you have it, okay? So from here, if I start with my earlier year, okay, and I jump to my later year, but again, kind of like that give and take method that we used when we were back in school, I want to get to that solid number again. We've talked about that a lot, getting to that easier number to make it easier. So yeah, I could definitely use my, standard algorithm and try and figure that out, right? But that might take me a little bit of time. Instead, I can just jump up from 1999 to 2005 rather quickly, and I will figure out that 6 years old is my answer, okay? So there's my answer for that one. All right, so again, I feel like I'm moving a little quickly here, and I apologize. but I do hope that you are following along and writing things down in your notebook as well, all right, or on your piece of paper. I'm going to go on to the next slide, which is the next problem, okay? So here we go. So if Timmy was 15 years old in 1996, when was Timmy born? All right, so thinking again of a number line, I'm going to try and use one that maybe isn't as thick as the one I used before. So, okay, this one's not as thick. So now I'm working with a year and the number of years that he was. So if he was 15 in 1986, when was he born? Okay, so if I put 1996 on my number line, and if I jump backwards and get to a solid number, okay, so let's say I jump backwards to 1990 for a second. I've gone backwards 6 years so far. Okay, I know that I need to go backwards 15 years, but now that I'm at 1990, it's much easier to kind of jump back a little bit. So if I jump backwards to 1980, I will have gone 10 years. So that's actually 16 years. So it appears that Timmy was born in 1981. So I'm going to go ahead and see if I'm correct, okay? Ooh, look at that. Okay, so notice how I jumped back 10, because for me that was a little bit easier. But if you already knew that you needed to jump back 6 and then jump backwards another 9 because 9 and 6 equals 15, then you, my friend, are much quicker than I am, okay? So now I know that Timmy was born, no, my Apple Pencil doesn't want to work, in 1981, all right? Okay, there we go, 1981. All right, I'm going to go ahead and move on to the next problem here. Here's the next one. If Kim was 8 in 2003, when was she born? So very similar problem. So again, I want to use a number line to help me with this one. So here's my number line. Okay, so my number line is like this. Okay, so I've got 2003. All right. I'm going to change my color here. Sorry, I forgot to do that. And if she was 8 in 2003, when was she born? Okay, so I'm just going to go backwards from 2003, 8 spaces. But I'm at 2003 already, and I know that if I just go backwards 3 spaces, I'm at 2000, right? Now, if I think in my head how many more spaces I need to go back, I need to go back 5 more spaces. And from 2000, it's pretty easy to do that, right? So if I go back 5 more spaces, 1995. Okay, so I'm thinking that she was born in 1995. So I'm going to go ahead and I'm going to switch over to the next slide. I apologize for my children in the background. All right, so just like I said, so this would be like the removing or taking away. So if I started at 2003 and I went backwards 3 spaces to get to that solid number that we have been talking about, that 2000 makes it so much easier to think about how much farther I need to go, right? So I want to go back another 5 spaces and I end up at 1995 because altogether 5 and 3 is that 8. So that tells me that 2003 minus 8 years means that she was born in 1995. All right. Okay, so there's that one. Let's see what the next problem says. Okay, so now I want you to think about it for a little bit here, all right? So when might someone want to find the difference in a subtraction problem? All right, so you want to find the difference in a subtraction problem when the numbers are close together. It's easier to find how far apart they are, okay? So the next thing is, when might someone want to remove or take away in a subtraction problem? that's when there isn't a lot of takeaway and it's more of a little number. All right. So you could tell that there was like kind of a difference between those. When the numbers are closer together, you're simply just finding the difference. When they're farther apart like that, you're simply going from the bigger number, the smaller number of spaces to get to that other bigger number, if that makes sense. All right. So I know, again, we've kind of talked about how you know how to subtract. I know that you know that, but I want you to try and embrace these two different ways of solving larger subtraction problems just to make it a little bit easier for yourself in the long run. It's just another way of thinking about things, okay? All right, moving on. So what I'd like you to do now is I want you to turn to the How Old page in your student book on page 139. So I'll give you a little bit of time to turn to that How Old page in your student book. While you are getting to that page, I'm going to go ahead and read the directions to you, okay? So the directions are, for each problem below, show your work, hints. Think about whether the numbers in each problem lend themselves better to remove or take away, or to find the difference. And then use labeled sketches of open number lines if you like. All right, so when I go to the next slide, you're gonna see that I have a little bit more room to work because this is a screenshot, obviously, of the slide, but I don't have as much room to work. So if I just switch the slide real quick, it'll be a little bit easier for me to show you how to solve these ones, okay? So you should by now be on page 139 so that we can kind of work on these together here, okay? All right, so workbook page 139. Let me flip the slide here. All right, so on this one, I'm gonna flip back to my pencil, sorry. And I will go to something a little bit smaller here. I guess this one's okay. All right, so Anna was born in 1997. How old was she in 2012? So I'm going to start by drawing a number line. So I want you to do the same thing with me here. Go ahead and draw a number line. I'm going to put 1997 over here. I wish I could use my Apple Pencil, but for some reason it's not working, okay? And we're going to be jumping to 2012. All right, so I'm thinking about that solid number that I'm trying to get to. So from 1997, that solid number for me, and I bet you're thinking the same thing, is 2000, okay? So when I think about from 1997 to 2000, I have gone 3 spaces already, right? Okay, so I've gone 3, that's a plus, sorry, 3 spaces. All right, so then I'm not to 2012 yet, but I do know that I have to jump 12 more spaces to get to 2012, okay? So I have jumped, whoopsies, I have jumped 12 more spaces. So altogether, how old was she in 2012? Now all I have to do is add the 3 plus the 12, and my answer is that Anna was 15 years old. And I have no room to write that. 15 years old. Okay, so there's Anna. She was 15 years old. All right, so that's how I do the first problem. Now I'm going to go ahead and do the next problem. And I apologize that there's not a lot of space here. All right, Craig was born in 1992. How old was he in 2007? So I'm going to go ahead and draw a number line. Okay, and I'm going to put 1992 all the way over here. All right, 1992. Okay, so I am again really close. So 1992 and 1997 are not that far apart. So I'm going to do the same thing I did before, and I'm going to jump to the year 2000. Okay, so I've now jumped to the year 2000, and I know that that's 8 years that I've jumped already, okay? And I'm trying to get to 2007. All right, so I'm going to jump to 2007, and that is easier for me to jump from 2000 to 2007, so that's 7 more years, okay? So 8 plus 7 more equals 15. So that means that Craig was 15 years old in 2007. Okay, so there's that one for you. Moving on to number 3, Peter was born in 1947. All right, how old was he in 2000? So you can tell that the numbers we're starting to get a little bit farther apart here. Okay, so maybe a little bit of a different jump here. All right, so here's my number line. Not the nicest number line, I apologize. I will get my Apple Pencil working. We're going to start with 1947. Okay, now I want to get to an easy number. So when I'm thinking in my head, 1947, I want to get to a solid number that kind of has a 10 in it. So, let me think for a little bit here. 1947 is very close to 1950, right? Which means that I will have jumped 3 years. Okay, so from 1947 to 1950, Peter went, aged 3 years, let's say. All right, so now from 1950, though, to get to 2000, that's going to be so much easier. Think in your head from 1950 to 2000. Ooh, okay, I got it. Sorry. That is 50 more years. So I have jumped 3 plus 50. So Peter was 53 years old in 2000. Okay, so now let's talk about Peter's wife. All right, so Peter's wife, Sasha, was born in 1949. Okay, 1949. Is she older or is she younger than Peter? And how old was she in 2000? This is going to be very similar to Peter's problem. Okay, so here's my number line. I'm going to go ahead and switch colors here again. So if Sasha was born in 1949, okay, and if I just jump like I did with Peter to 1950. 1950. Ooh, I only had to jump 1 year. Okay, so I've jumped 1 year, but I'm still needing to get to that year 2000. Okay, so I'm going to jump again, and it's the same number of years that I jumped with Peter, right? 50 years. So I will have jumped 50 years, which means that Sasha was 51 years old, because 1 plus the 50 that I jumped equals 51 years old in 2000. So the first question was, is she older or is she younger than Peter? Well, it appears that Sasha is younger than her husband, Peter. All right. And then the next one was, Emma was born in 1963. How old was she in 2002? All right, so here we go. 1963 is going to go on this side. 1963. Okay, so I'm trying to get to that solid number again, and I'm really close to 1970. All right, so I'm going to put 1970, and I'm going to jump. That's 7 years already, okay? So I've jumped 7 years, and I'm thinking of another solid number. So 2000, to jump from 1970 to 2000, that is another 30 years, because from 70 to 100 would be 30 years. So from 1970 to 2000 would be another 30 years. All right. I'm not quite there yet, though, because I don't need to get to 2000. I need to get to 2002, right? So how many more years would I need to jump to get to 2002 from 2000? Okay, I think I've got it. 2 more years. So 7 plus 30 plus 2. 39 years. So Emma was 39 years in 2002. Okay. All right, so now the last problem on this page says Emma's husband Tom was born in 1961. Is he older or younger than Emma? And how old was he in 2002? All right, so I'm going to draw another number line. All right, here I go. Here is my number line. Okay, so I'm going to go and put 1961 right here. From 1961 to 1970. Whoa, sorry, that does not look like a 70. All right, that is 9 years. Okay, 9 years. Again, so thinking back to this problem we just did a little bit ago, from 1970, I'm going to fix my 0 here. That does not look like a 0, and I'm sorry about that. Let me make my 0 a little better. That's a little better, sorry. From 1970 to 2000, I'm going to do that one again. Again, I know from before that was 30 years. So I've jumped 9, I've jumped 30. My 30 kind of looks like a 36. I'm so sorry. Let me fix that again. We are all in this together, right, boys and girls? Yes, we are. Okay. So I know that's not the best. All right, and then I need to jump 2 more years again. So to 2002, 2 more years. So if I add these together, 9 plus the 30 plus the 2, that equals 41. All right, so that means that Emma's husband, Tom, is he older or is he younger than Emma? He is older, and he was 41 years old in 2002. All right, so there is how old Tom is. All right, going on to the next slide here. So here are the answers. So we had 15, 15, 53, 51, 39, and 41. Let's go back and see. Yep, look at that. Let's see here. We got 15. We got 15. We got 53, 51, 39, and 41. Sounds good. Nice. Okay, so here's the next page. This is student book page 140. So it says, if the telephone was invented in 1876, how old was it in 1991, and how long had it been around? So if I draw a number line for this problem, and I flip my color again, and I put 1876, okay? I want to get to that solid number, so I'm going to get to 1880. I want to get to 1880, and that would be, I'm not sure what's going on here. That would be 4, okay? So that was 4. Now from 1880 to 1900, that's another 20 years, okay? And then from 1900 to 1991, whoa, what is happening here? I'm not sure what's going on here. 1800 to, wow. I don't know why it's doing that. I'm so sorry. To 1991, that is 91 years. So if I go and add these together now, 4 plus the 20 plus 91, that, my friends, equals 115 years. So that means that the telephone, which was invented in 1876, how old was it in 1991, and how long had it been around? It had been around for 115 years. That's crazy. All right, so moving on to the next one. So the stethoscope, which was invented in 1819, how old was it in 97? Ooh, I'm going to zoom in a little bit here, see if we can make a little bit more space here. Okay, So 1997. So we'll make our number line. We can make it a little bit longer here. All right. So we'll go with 1819. All right, from 1819, I'm going to get to a solid 1820 here. 1820. So we'll go, that's 1 year, right? So we've jumped 1 year so far. From 1820 to 1900. Get to another solid number. That's another 80 years. And then from 1900 all the way to 1997. That's another 97 years. So altogether, we have jumped 1 plus 80 plus 97. That is 178 years, which means that the stethoscope was 178 years old in 1997. Holy cow, that's crazy. And then finally, if the battery was invented in 1799, how old was it in 1998? So this will be the last problem that we do. These challenge ones, you can do these ones at a later date if you would like to, or later after this lesson, all right? We're gonna do one more of these. So just go ahead and follow along in your book with me while I do this last problem. So the battery was invented in 1799. How old was it in 1998? Well, 1799 to 1800. That is 1 year. Okay, now I'm going to get to 1900. Ooh, how many years is that? That is 100 years. Wow. But I don't need to get to 1900. I need to get to 1998. So 1998, that's another 98 years. So add those together. 1 plus 100 plus 98. My friends, how many years is that? 199 years old. Wowzers. Okay, so that is how we are doing this part of the lesson, okay? And like I said, this challenge, they're all really the same problem, but what you're trying to do is figure out what various numbers can you use here. And it's actually, there's more than one correct answer. So tomorrow we could do that, or we don't even need to really worry about it. It's just an extra challenge for you. So I'm not too concerned about it at this point. All right, I'm gonna go on